Welcome to Making Stuff with Chris DeHut. Today we're going to be talking about interfacing the Raspberry Pi PICO with the very simple 7-segment LED display. These are very powerful communication devices and they should always be considered for communicating information to a user when working with microcontrollers such as the Raspberry Pi PICO. What we're going to talk about today will be what they are, applications for them. We'll go over a datasheet example. Most of them are pretty similar, so this generic datasheet will cover most of them out there. We'll be looking at example wiring via a Fritzing diagram, and then of course we'll also be looking at the actual device on a breadboard. Then we're going to go over 3 different programs that will show various capabilities of the device. The first one will be just simply turning on each of the individual 7 segments, showing how we can control each of those little elements. Then we're going to go through, show you a program running, or show you how a program displays numbers with the device. And then finally we'll show you a way to communicate a 4-digit code with this type of device. So let's get started right away by looking at what the device is, and we'll do that here on the breadboard. Now, as you can see, it's a very simple device. In this particular case, it's a single digit. They come in multiple digits, but that would require an interface driver chip in between your PICO and the unit. And we'll be covering that in a future video. But what we do want to cover today is how to communicate with this, how to turn on the segments, and of course show you numbers and a coded message. Applications for these are often found in industrial devices or home appliances and so forth. For example, the furnace in my home has a 7-segment LED on it. Here are some photographs of 7-segment LED devices on industrial devices. An air compressor, an industrial air compressor, a dryer, another industrial device. Here's one that's on a modern machine tool communicating what mode of operation the device is in and the current temperature of that device. But nonetheless, their main objective or goal is to communicate a number. And with that number, it could be a code to a more in-depth explanation of something. So now we can go ahead, now that we know what it is and why you would use it, let's take a look at a King-Bright datasheet covering a 7-segment LED. The first thing you'll notice in their drawing here, they're showing the package dimensions, which are always helpful because you want to kind of know how big the thing is, length of pins, etc. But what's really important is really kind of hidden in this image right here. Now I'm going to zoom that up, and I want to get down so we can see this. Now what they're showing in this schematic is each of the segments and which pin number is associated with turning on that segment. So if we look here, it's hard to see, the image is not very clear. This is segment A, B, C, D, E, F, G. And then down here would be decimal point 1 and decimal point 2. Now here they're showing us that pins 3 and 14 are on the cathode side or the ground side, and then these are all on the positive voltage side, the anode side. And segment A is controlled by pin 1. Segment B is controlled by pin 13. C by pin 10, and so on. Decimal point number 2 is controlled by pin 9. So that's how you figure out what wire to connect to which pin to get a certain segment to light up. Now, more often than not, they will have just a single color. I haven't seen too many multicolor units, so when you need to pick out your current limiting resistor, we will need to look at that information, and it's not as complex as, say, a bar graph where you're working with 4 or 5 different color LEDs. So here we're just going to be picking one color, and that would be Here they're showing this is a white diffuse lens with a red emitting color. And what they want to let you know here is that it should be at 10 milliamps, and here is what they're describing you will get with that, or 10 milliamps. And 10 milliamps is pretty common for most LEDs. We want to look at the forward voltage. It's somewhere between 1.9 volts and 2.3, so we would say 2.1 would be our forward voltage at 10 amps, and that's when the LED would turn on. So we would calculate our current limiting resistor on this 10 milliamps. If you aren't familiar with how to do that, please look up our video on the single LED video for the Raspberry Pi PICO series, and we go into that formula to show you how to use it. The one thing I'd always point out on data sheets, absolute maximum ratings are not to be used. If you run it at DC forward current, maximum value 30 milliamps, odds are really good the LED will not last very long. And then you can always look on your graphs. They often tell a better story. We're always concerned with forward voltage, that's the voltage at which the LED turns on, and the forward current. And we can always cross-reference that over to here, and 1.9 is when the voltage, when the LED comes on, the minimum value at 10 milliamps. So that's how you correlate milliamps with voltage and where you want to be, that so-called sweet spot. The other graphs will communicate other information such as luminosity, intensity, brightness, if you will, at the current level. In this case, we're talking about 10 milliamps as being a good number. So right here would be what they're describing, the spot right at that point. Another handy thing on all data sheets, or almost all of them, the good ones, they will provide some information about a typical circuit. Here they're showing an invalid setup or circuit for a 7-segment display. They're showing one resistor here to limit the current for all the LEDs. That is not the proper way to do it. We need to have one resistor for each segment, which is one LED. So 7 segments plus the decimal point, you'll have typically 8 resistors and then 8 total segments. 7 is what makes up the actual numeric value. Now let's take a look at the Fritzing diagram, which is a little easier to see than the breadboard because of the sheer number of wires that we've got going to both sides of the device. What we've got, we're going to take our ground from the Pico, put that on a ground rail, and then that has to connect to the ground points or the ground pins of the 7-segment display. So there's one there and one here. Now each of these wires and these 4 are positive voltage wires. They're outputs from the Raspberry Pi PICO, putting 3.3 volts into the device. And what we have to do is go through our current limiting resistor. And I've picked 220 ohm for the resistor just because when tinkering on a breadboard, I'm not necessarily looking for maximum brightness or anything, but I am looking for protection so that I don't short something out. And if I do, having a higher resistance or a higher ohm resistor, we can protect the circuit or the device from being burned out. If you watch my bar graph video, I burned out one of them by short-circuiting something, one of the little segments. But you would use the actual value in your actual circuit. If you don't want to go through the trouble of calculating it, usually 220 ohm resistors work fine for red LEDs. But nonetheless, we're just going from the pin through the resistor and to whichever segment we're assigning this pin to control on the 7-segment LED. And as mentioned, one of these will be the decimal point, which is right underneath my cursor here. Now let's take a look at this on the breadboard. Coming over here, we can see we've got our Pico. Here's that ground wire. going from physical pin 3. Here's our ground rail, feeding ground or providing 0 volts to the 7-segment display. Here's each of our pins connected one by one through the current limiting resistor, looping around and connecting to the pin associated with the appropriate segment of the 7-segment display. As you can see, this does look really kind of spooky in here. It's really not. It is truly as simple as the Fritzing diagram. It just, when the wires loop over each other like that, it does seem to get rather confusing. So now let's take a look at the program and how we control this. Now this particular program, 7-segment LED display, you can download from our website. Links will be down below, as well as the other 2 related programs. The comments try to make clear what is what, which LED segment is connected to which pin on the Raspberry Pi PICO. The 7-segment display has 8 total segments because of your decimal point, which is noted here with DP LED. We're going to import a couple of libraries. We need to import the machine library, which allows us or provides us access to the mechanical devices or the I/O pins of the Raspberry Pi PICO. And then we're also going to import the MicroPython version of the Python time module. That'll allow us to put short delays in the program so that we can animate the sequence. In this area here, we're just creating our LED objects for each segment on the 7-segment LED display. So for example, letter A, LED equals machine.pin number 16. That is the GP number of the pin, and we're setting that pin as an output by the notation .out. And we need to have one of these objects for each of the segments on the LED display. Then we're going to go ahead and just print a message to myself. We're going to give ourselves a variable here to define a delay in between each one of these on-off sequences. And before we go into this section, I'm going to run it over here on the breadboard so that you can see what this program does before we explain it. Now, as you can see, I'm lighting up each one of the segments in sequence, A, B, C, D, E, F, G, etc., going through. I'm not creating numbers or anything. I'm just turning on and off each one of the individual segments. And that's what we're doing with all these wires and the program. So let's look at that in code. We're in an infinite loop here. I'm going to turn on the A segment, the A LED, by setting its value to 1. That's turning it on. Down here, I'm going to turn it off. A LED value set to 0. That turns off an LED, or turns off the output. Coming back up here, we're going to go into a short delay using utime.sleep. That's a sleep sequence. And we're going to delay for the amount set in variable sequence delay, which is 100 milliseconds or 1/10 of a second. And we're going to turn on each of these segments one by one. When we get them all turned on, we'll rest for a minute, and then we'll turn them off in the same sequence. Turning them off one by one, then we'll sleep for a second, and then repeat infinitely. Back at the breadboard, you can see how that's operating. Now this isn't really useful, it's just more of a demonstration to show you what we're really doing with all of this is controlling each one of these LED segments to be able to create different characters out of that display. So now let's go on and show you how to use different or display different numbers with this display. And that's a different program, so I'm going to click on it. I already have it open here. And I'm going to run it before we describe what it's doing. Here we can see it's counting up from 0. We're delaying about 1 second in between each digit. Now it'll reset back to 0, counting up to 9. And the last one at 9 will show the decimal point being lit up. So let's see how we do that in code. All this upper part's the same. We're creating our objects, our LED objects. But I added a couple of functions here so that you could utilize this in your own programs as well. And what we've got is one of our functions is to clear the display, to turn all of the segments off. Very simply here, we just go through one by one, turn each segment off. Then we're going to show a number with this function. And we will pass it in, this function, the number we want to show, and whether or not the decimal point should be on or off. So the first thing before I show a number is I want to clear the display, because if there's a segment left on, I'm not turning it off in this area. So we want a clear display when we start. So based on the number passed in, if it's number 0, we need to turn on the outside edge segments. So back at the breadboard, so we're going to turn on the top one, the bottom one, the 2 left side ones, and the 2 right side ones. And that's what this would all be doing here. Again, remember, these letters here relate to the data sheet showing you which segment is A, B, C, D, E, F. Going down the line, just depending on which number it is, we're going to turn on those specific segments to get the number. So it's a very handy function for you to use in your programs. Now we'll look at the loop that's running to show these, or sequencing through these numbers. We're going to have a 1 second delay in between each number that we display. We're in an infinite loop. So I'm going to use that function, show number. Go back up here. There's our show number. Back down to here, show number, number 0, and then you'll notice I've just got nothing between the quotes over here, which is whether or not I want to show the decimal point. And if we come down here, you can see when I show number 9, I'm also going to show the decimal point. But we'll show each number one by one, and then we'll have a short delay of about 1 second, or exactly 1 second, between each number being turned on. And then this just repeats through and through. Now you can use this in your programs, and most probably you might just set one number and of course not be in a loop like this, but then again you may want to. It just depends on how you want to communicate that numeric value to someone. Now let's take this to the next step. This is great. We can communicate a code between 0 and 9 with just one little device. But let's say you need to communicate more than a code of 0 to 9. And what we're going to come up with is a routine that will display 4 digits with a marker character in between each of those digits, so that you know when the sequence starts, or the coded message starts. Now let's take a look at a way to communicate that 4-digit coded message with this program. It's called 7-segment 4-digit coded. Comments up above are very much the same. We are going to load our libraries. We're going to create our LED objects. We've got our clear display function. We've got a new function called marker code. And what we're going to do with that marker code is we're going to turn on the needed LED segments for that marker. And that'll be the A LED, the D1, and the G1. Over here at the breadboard, that would be the 3 horizontal lines here, here, and here. So the top, the middle, and the bottom horizontal lines. And what I want to do is flash that quickly so that we can see something is unique. It's not a number, so it's communicating us a marker in between a message. Down in here, we've got our show number function, just as we had before. That's nothing different there. And here is a function that I'm calling our 4-digit code. And down below, we will create a code, pass this function that code, and then we'll show it for 1 second. Now that code will consist of 4 characters or 4 numbers, 1961 in this example. So what we're going to do is we're first going to show our marker code. So t is just a counter for the number of times through this loop. So while t is greater than 0, I'm starting at 3, so when I get to 0, I won't go for a 4th attempt there. We'll clear the display. We're going to sleep for 50 milliseconds. I will display the marker code. Then I'm going to sleep for 50 milliseconds, decrement our loop counter, and then repeat that a total of 2 more times for a total run of 3 times. So I'll flash very quickly. Then we will clear the display and then sleep for about 100 milliseconds before we actually show the 4 codes. Now the first thing I'm going to do is just do a quick test. This was probably put in here more for debugging, but we want to make sure that the length of our code is less than 4 characters. In truth, you could put as many as you wanted there, I guess. My original intent was a 4-digit code. So that's what this checking is. Now we go into the loop for C in code. And what I'm saying there essentially is I want to look at each character, C, in the coded message of 4 characters. So I'm just going to use a local variable here called showCode so that a little easier to understand on the next line. We're just going to assign that the value of C, which is one of the 4 codes in the coded message. So we'll show that number, whatever value or whichever one of these digits we're looking at, it'll show it for 1 second, and then it'll repeat it and then go through. So it'll show 1, pause a second, 9, pause a second, 6, pause a second, and then finally 1. Then this loop is running continuously, so it'll sleep for a second, then it's going to repeat all the way through to show the marker code again, and then the 4-digit number. So let's take a look at that on the breadboard. There's our marker, 1961. Marker, 1961. Now, as you can see, that could be extrapolated out to communicate any number of numbers that you wanted to display. Furthermore, the 7-segment display is not just restricted to numbers. You can also kind of come up with alphanumeric characters with this device as well, just by turning on the specific segments that will give you the graphic representation of a letter or a number or other symbols as well. And that's pretty much going to wrap up this video. As I alluded to earlier, if you want more than one 7-segment LED display to be driven by your Raspberry Pi PICO, it gets harder and harder because you've only got so many GPIO pins to drive the LED display. It really needs 8 pins for each one of those digits. There are driver chips that are very useful for that, where you can drive up to as many as, I think, 8 digits. So we'll go into that in a future video. And I would also like to mention that I have a number of other videos on the Raspberry Pi PICO interfacing with many other objects. And I try to follow a similar format where we talk about the device, the applications for it, datasheet references, as well as the wiring of it with the Fritzing circuits, and then several practical example programs to help you along the way. Those can also spawn some creativity for you in your projects. Well, I hope you enjoyed this video, and I really appreciate you spending time with me today. If you haven't done so, please subscribe, click the like button, and the notification bell. I guess that notifies you whenever I publish a new video. Thanks again for watching, and I look forward to seeing you in the next video.